Welcome back, everyone. Kevin Carpenter here again with another interview. One of our upcoming instructors, Matoush, is giving us a class on structured concurrency in C++. And I want to say, like most of your classes, Matoush, a hands-on workshop, right? Definitely going to be writing code in your class.
Yes, there will be plenty of that. Yes, this is my style. We are really teaching our fingers how to type code on my workshops.
So if you don't know Matoush, just Google, because the amount of talks you've given, your Unix library, working with the ISO C++ standard committee, you spent years with Intel, and now you're at EPAM Systems, right?
Yes,
With C++.
yes, that's correct.
But more importantly, I mean, if you want some great training, you can always find Matoush giving great training, and that's what we're here to talk about. So this is for your class at ACCU. Starts the 29th of March. Is that correct?
I think so. Yes.
Yeah. And so let's start off. So why is asynchronous programming and parallel programming, even more important now in modern C++?
Well, actually, I wanted to say not that long ago, but actually, well, time flies. It's actually a long time ago where the CPU's frequency stopped to grow, right?
Yep.
Like 30 years ago, we were saying, okay, if this works slowly on your computer, just wait 2 or 3 years, you will buy a faster PC later on with bigger clock rates, and it will just work fine. It's not the case anymore. It's not the
Yeah.
case for many years right now, right? Our CPUs are not getting faster. We just can get more CPUs, and this is what
Yeah.
makes the computers faster. So this is why we do more and more things in concurrent, parallel way, depending on the structure of your program, and we want to benefit from this hardware concurrency that we have in the code, right? Because it's no longer like it was before, like a software concurrency with task switching or with multi-threading on a single core, or which basically is a bit different story, right? Because I've even heard a quote some time ago that, well, multi-threading is for people that don't know how to write finite state machines. But that's not true anymore, right? Because if you have
Yeah.
several cores, then you can actually do parallel work, real concurrent work, rather than just simulate one.
Yeah. So it's interesting on the limit of the CPUs, because I was watching a talk the other day, and it's like I think we've capped out 3 gigahertz is about the fastest that they can make the CPUs go now, and that's
Yeah,
just
something like this, right? Maybe a
yeah,
bit more, but yes, this is where we ended up, and it doesn't get faster, right? So you have to
yeah.
benefit from all of those possibilities, from CPUs, multi-core, GPUs, with plenty of cores, and basically this training is about trying to teach you how to deal with the concurrent code, how to deal with parallel work, how to deal with
Mhm.
asynchronous work. Asynchronous is not always about concurrency, but still really important thing. How to deal with those in an easy way, easy to maintain, easy to reason about, easy to refactor way with the C++ code.
So, what are the limitations of the C++ standard library's current concurrency primitives, do you think?
Well, what we have in the standard library is great as a low-level building blocks for everyone. But when I'm trying to build something bigger, with those blocks, I feel like I'm doing like programming with GoTos from 60s. Those are just low-level building blocks, and you just have to think about it, everything by yourself. You have to add callbacks everywhere, and then preserve state between those, and basically, it's really hard to reason about the pipeline, um, about the thing that you want to implement in
Mhm.
a way of parallel callbacks. Of course, we can use like .then continuations for non-standard futures because standard futures do not have .then, but there are some extensions. But still, it makes like lambdas in lambdas in lambdas in lambdas, and this makes it really hard to reason about and debug, right? So with the structure concurrency, you basically write as a sequential code that runs concurrently or asynchronously, and
Mhm.
this is so good, right? Everything nests, so you have scopes, you have variables, those have lifetimes, so you can use array AI, and you don't have to reason about anything. You don't have to allocate anything on the heap in order to preserve state from one place to another, from one callback to another callback, and so on. It makes it so much easier.
That's interesting because I do remember when I was first learning about concurrency, having to really get into the meat of a mutex, Is that still like a? I mean, I understand like we want to understand what a mutex does, but in modern concurrency that we're doing in C++ now, how often do you run into that? I mean, aside again, like I'm like I get the premise of understanding it, but how often are you actually having to use it?
Um, Less and less, I would say, especially after C++ 20, we have much more primitives in the C++ standard. This training is maybe not about that. I provided this training on the previous conferences,
Mm-hmm.
but we in C++ standard library right now we have latches, we have barriers, we have semaphores, which are really
Yeah,
great abstractions that can be used instead of mutex and logs and condition variables, which were quite cumbersome to use.
yeah.
And often the new abstractions are also faster at runtime.
No, it was just kind of that question of how the standard library's current primitives. It just made me go back to like std mutex. I'm just like, you know, and that's that part where there's so many other options that are available now. So you were saying structured concurrency, and so I'm curious, how does that help simplify thread safe code?
Um, Structured concurrency is totally opposite of what we had before, right? So it's
Mhm.
writing the code that basically uh, you can reason about as a regular function. Like with
Yeah.
coroutines, which are also structured concurrency, you have one entry point, one exit point, scopes nest, variable nest, lifetime nests, RAI works. Everything about it is true. The same is for send as receivers to the execution framework, where you have the same. They have a bit different use cases. I think the at least tasks, a concurrent task, the coroutine task. Coroutine tasks are more about the asynchronous work, although
Hmm.
they can also model concurrent things, especially if you're doing something like an event loop. And then
Yep.
you can basically in one thread, you can handle all of those things asynchronously and have those concurrent stuff being done asynchronously. But more about data parallelism is for with send as receivers, where you actually can define pipelines of your processing of the work in a really nice way, where you say that there are like many pipes in parallel where you're processing data. Then you can split data, you can aggregate the data, or basically do some bulk processing. All of this allows us to reason about really nicely on the high level how the
Hmm.
execution of the program flows with all of the typical C++ safety stuff related to lifetimes and array idioms.
So that's going to lead me to two questions. And the first one, just because you mentioned both of them. So how does senders and receivers and coroutines, I mean, one, like, how do they relate? Because, for the last couple of years, coroutines were the big thing. And then I noticed like last year, we started to see a lot more talks on senders and receivers. And so, first, how does it relate and how do you explore that in your class?
Yeah, so of course, coroutines as a language feature are great. And the fact
Hmm.
that it's a language feature, it allows libraries or tools from different vendors to cooperate with each other. So, for example, the task from send as receivers library and my library and maybe standard library in the future, because we just agreed on the design. Hopefully, it will end up in C++26. All of those will cooperate together. So basically, coroutines is a language feature and is a great stuff. However, in coroutines, it is hard to express some things. For example, coroutines do not have cancellation.
Okay.
So you cannot cancel the job easily. Coroutine also have this inherent allocation that potentially may be elided by the compilers, but many people say that, well, this is the overhead I don't want to pay for.
Hmm.
Although typically when they were doing the same with ASIO, they were just allocating shell pointers everywhere. So this is the same overhead, right? I will not say this is an issue, but if you will measure that actually this overhead is actually a bottleneck in your software, then you're looking
Hmm.
for something faster, right? Send as
Yeah.
receivers, on the other hand, is a library feature, not the language feature. But it is designed in such a way that it actually supports cancellation because it's a more modern design, and also provides you the possibilities to actually not allocate anything. On the other hand,
Okay.
it's really hard to write your custom sender. Writing custom senders is quite hard comparing to code of coroutines. I'm not talking about writing the coroutine types like task or generator, because those should be provided for you by library vendors. But writing
Hmm.
your custom coroutine code is just writing regular C++ code. Writing your custom algorithm for sender receiver framework is quite hard. And often it turns out that it's easier to write a coroutine doing the same. If you can basically pay with this additional allocation and you don't require cancellation, then it's fine. Uh, So that's why the send receiver framework wanted to benefit from coroutines, and actually every coroutine task, uh, if it's actually properly implemented, and the one in the standard will be, it's a sender. So you can connect a task coroutine into the sender pipeline easily. So every coroutine returning a task will be returning, having a return type as a task will be a sender that you can connect to the pipeline, which is great because you can easily write every logic with regular C++ code and have it work for you. Only if you cannot agree on this allocation, you can write your sender block by yourself. On the other hand, many senders can be await tables in coroutine world. So you can also co-await senders in the coroutines. So basically, you can interaction in both ways, and that makes both of those features really nicely working together. That's why I'm actually talking about both of them at the same workshop.
So, out of curiosity, because I know we were talking before that, parallelism and concurrency is something that you've been, working with more lately. In your mind, it seems to me like the concepts might be harder than the code at sometimes. Like when we're working with data parallelism and such, we always have the problem of like, shared state, mutable state, and whether one, when I'm talking older threads, whether you were writing where you shouldn't and such. And what I'm feeling like is we're now getting the tools that helps manage that better, but it does still seem like, even talking about structured concurrency, the mental model that you end up having to build about all the different objects, because I mean, the code is there, right? We have the examples that you can follow. It seems more of that. I like to joke that part that I watch a YouTube video about brain surgery does not make me a brain surgeon until I actually, do the task. So it seems that same way with whether sender and receivers, coroutines. You got to sit there and write the code to get that mental model built. Would you agree with that? Do you think that's how you came about it?
Yeah, of course. Actually, this is why I say that my workshops are always about hands-on experience, right? I found it on many exercises and many different trainings I provide to my customers that I often provide plenty of slides saying this is how you do things. For example, type traits, right?
Mm-hmm.
This is how you write type traits. This is how you build type traits, returning values, returning types, and so on. And then I asked the students to do something much simpler that was on the slide by themselves, and they don't know
Yeah.
how to start. They have to basically learn it by experience, by typing. And after a
Yeah.
while, they get fluent with that and they know how to do it. They know what to passive specialization or full specialization. They know how to type it. And then it gets easy. But you have to have experience with this, right?
Yeah.
The same goes for the coroutines. For example, coroutines is the most complex feature in the C++ language, in my opinion. It's not hard, and the design actually is sound, but there's plenty of things that are going on, plenty of moving parts that you can customize. Wrapping your head around all of this at once, it's really hard. And
Yeah.
that's why by doing exercises, we learn step by step how to implement a task coroutine by yourself, which is really, really great, I think. It will be even needed when it actually appears in the standard because uh, standard right now will have generator and the task. And
Mm-hmm.
that may be useful for many use cases, but still you may end up needing to write it by yourself for some special needs. For example,
Yeah.
I just finished the same training for one automotive company, and they are doing everything in a big event loop. And in a big event loop, then the regular task and sync wait will not work for them. They have to actually write their own coroutine return type in order to provide their own behavior for the coroutine task-like thing, and they basically benefit a lot from the training that we had for last 3 days, right? And this is basically why we are doing that.
That's
And basically, yes, talking about coroutines, maybe one more thing, or I can actually talk more, but coroutines are actually really great. And it's actually, if you attend the training and you see all of those UML diagrams and sequence diagrams, how the things interact with each other, you will
right.
find out that there is no need for manual synchronization between stuff, even though you're doing asynchronous or concurrent work. And that is so awesome. The design of
Yes.
coroutines, for example, enforces correct behavior. You don't have to synchronize anything. You don't have to pay for mutexes, logs, unlocks, and so on, because everything is
Yep.
synchronized by itself. And learning this actually is mind blowing for some on the training.
So like I said, the last time I took a concurrency class was 2018. So to hear and to see the outline of what you're going to be teaching. So if you want to get a modern pull on concurrency in C++, you want to take Mateusz's class, and at the end of the video here, you will find a discount code for it, as well as a link to his, outline. I was going to say syllabus, but by all means, get more experience in concurrency. Join Mateusz ACCU this year, and thanks for joining me this morning. Well, my morning.
Yes. Well, it's my afternoon, but yes, it is really always pleasure to talk about C++, and I really look forward to see every one of you on ACCU, a conference, which is really, really great, even if not attending the workshops. And of course, I hope to see you on my workshops or the workshops of other trainers, because actually during the workshops, you learn the most. That's my opinion, at least.
Absolutely. Thanks, Mateusz. Have a great afternoon.
Thank you. Bye-bye. See you soon.